Right? You all here? Nice. All right, so today we want to finish up the remaining topics. Before we go into it, there was something I forgot to do yesterday in Triggs. Anybody recognize? There was something I forgot to do. Right? If you're on the ground, right? If you are on the ground and you're looking up at something, that's an angle of what? Elevation. All right? So let's say you're looking up at an angle of elevation of 30 degrees to the top of this building. Then you look up at an angle of elevation. That's okay? So I forgot to mention that, right? So up is an angle of elevation. Suppose I set an angle of depression of 30 degrees. What will that be? You're looking down, right? And here's how you draw it. You have your horizontal and you measure 30 degrees looking downward. Right? This is your angle of depression. If I say that, it's from the horizontal. Don't measure it here. Right? That'll be angle of depression, and this will be the angle inside the triangle. What angle we obtaining here? What angle we obtaining here? Most times 90 degrees. So what type of triangle you working with? A right angle triangle. That's okay? So I remember that we're working with right angle triangles when it comes to elevation and depression. Okay? So again, look it up from the horizontal, elevation. Right? Looking down from the horizontal, depression. Okay? Got okay with that? So I wanted to go over that because I didn't get to do a question on that. Right. So that leads us into three of the bigger three of the challenging topics. Well, matrix is kind of easy, right? But this leads us into vectors and angles and circles. Right? The only bad thing with angles and circles is I should have made you try to learn it off yesterday. So when it comes today, you have an idea. All right, but let's see if you knew them already, or let's see if you could remember them from today. All right, we're done with stats, we're done with that, we're done with functions, quadratics, we did a little construction. Now for circle theorems, right? Right? Circle theorems, besides learning the rule, you have to be able to, identifying the rule, you have to be able to write it. So when they ask for a reason, you have to be able to say angle in a semicircle is 90. All right? So you have to learn those rules. So we're going to do a whole set of these today. Okay? Sometimes this has come together with the bearing question, right? All right, first one. If you have an angle in a semicircle, the angle is 90. You're seeing that? What you must recognize is that the diameter forms the triangle. You're seeing that there? The diameter forms the triangle. Okay? And the angle of the circumference is 90 degrees. Right? So for those who it for the first time, you could probably open up this on your phone and have it when you're doing question, right? Next one. If you see a shape like this, angle at the center is twice the angle at the circumference. Right? So the angle at the center here is 120. The angle at the circumference is half of that, which is 60. Right? This is your circumference, right? You okay with that? You're seeing this rule right here. Anybody seen that rule in the first rule? It's rule 2 and rule 1. You all seen it? What's the angle here? 180. And the angle here is half of that. All right? So you have to be able to look out for this shape. This shape, when extended, looks like this. So these two rules link, right? Next rule. Right, next rule here. This rule is sometimes tricky to see, but try to remember this. When you have a circle and you have a chord, right, that chord is forming two triangles. Same chord, forming two different triangles. Once you see that, angle at the circumference equal. That's okay? Next one. This one kind of easy to identify. It must be a cyclic quadrilateral. What does that mean? It means that all four sides, all four vertices touch a circle. Okay? All four vertices touch a circle. Once you see that, right, opposite angles sum to 180. Okay? This is one of the first shapes you can look for. Next one is a nice easy one. When a radius meets a tangent, the angle between them is 90. Right? This is one of the harder ones to see. When you have a triangle and you have a tangent at one of the vertices, these alternate angles here equal. Right? This is one a little tricky to see, right? So if you find none of the rules that you know not working out, then go to this one. Look for the triangle, look for the triangle, look for the tangent, and remember that these alternate segments here, all these alternate angles are equal. That's okay? Next one, right? Whenever you have two tangents, when one chord have two tangents, it forms a isosceles triangle. So the angle here and here equal. Okay? So you have one chord and at each point it has a tangent. Right? That triangle forms isosceles. Okay? And then, well, if you have a radius passing through the midpoint of a chord, the angle is 90. I just hardly ever see that. Okay, so these are the rules. The trick is now to be able to see these shapes and apply the rules. All right? If you didn't memorize it, just do me a favor. Open up your summary into this page. Right? Let's call it rule 1, 2, 3, 4, 5, 6, 7, 8. So as I move along, I will say, okay, rule 1 or rule 2 or rule 3, right? So you don't have to write it out in full now. Open it up, take a picture if you don't have it, screenshot it, or you have to write them down. Let's do a couple of these, right? Okay. All right, so let's take a look at some of these questions, right? Let us start with, I want to do a few of these, right? Let's hope we catch them. We gotta get them. Hey, papi. Nice. This topic is called circle geometry. All right, let's start with the easy one here. We don't need, I ignore him what they ask us, right? We ignore what they ask us. Let's see if we can apply the rules, right? So what you see here? Look at the shapes. Which rule you'll see in first? Which one? Angle at the, guess what? Half the angle at the center. Okay, you all saw that. So the center here is what? 1. So we 58 by 2, right? 116. Look again. Look for the shapes. Look for the shapes from the rules. Everybody see the next shape? Look at the overall shape of the shape in this circle. What's the overall shape of the shape? Inside the shape. What's the shape? A cyclic quadrilateral. You're seeing that? RSQP. Cyclic quadrilateral, right? So therefore, this angle here is what? That angle based on the rule is what? 180 minus 58. Right? Because this is the opposite side, right? How much is that? How much? 122? Yeah, 122. All right. Right? So we have 122 here. You all seen anything else? Seen anything else? There are no tangents, right? There are no tangents, so we can't use any of those tangent rules. Right, Sierra? What about rules on the inside? Look inside the shape. OS is what? OS is a what? A radius. OQ is a what? Is a radius again. So what shape is that? Isosceles, right? So the angles here and the angles here are equal. That's okay? Right? The angles at those 2 points are equal. Everybody okay with that? Work it out for me now, please. How much you'll get there? How long I start? Since 8 o'clock I start. Since 8 o'clock I here waiting on you. I cannot believe that. I guess at 8 o'clock waiting. Yeah. What's the angle? How much? 32, right? So remember to get the angles here, 180 minus 116 over 2. Okay? So that's 32, 32. Everybody okay with that? So based on what we have, we could kind of guesstimate what here will be, assuming those two equal. But we can't say that, right? And we don't have enough info. So let's see what they asked us for. I'm taking it off. Let's see what they asked us for. They asked us for SPQ, that's right here. What's the rule for that one? The cyclic quadrilateral, right? You're okay with that? And then they asked us for OQS right here. So you will work out here and then use isosceles triangle. You're okay with that? Please remember, OQS means this, right? O, start at O, QS. So the angle in the middle is what you want to find. Everybody okay with that? Right? So that was a easy one. Anybody confused? Again, the only way to really do this is you have to know the rules, right? But for now, you should have the rules in front of you. Y'all okay with that? Right. So before we do the next one, I am not going to show you what they asked for. Ooh, no. I'll skip that one for a little bit. See what you can find here. See what you can find here. Right? Without looking at what they're asking for. Draw the shape. Draw the shape in your book. Just a little sketch. Draw a little sketch in your book. Good. draw the circle for you. Draw it, label it up, and by just looking at the rules, see if we can figure it out. See what you can get, right? So I want you to get an image of the rules in your head. See what you can find, right? Right? Look for where the tangents meet the radius. Look for any shape you can find. Right? So this diagram has tangents. So more than likely you're using the rules that have tangents in them. Okay? See what you can find. You have the rules. You have the summary. I love the summary so you'll be able to get the rules. You don't have it? The summary. The math summary. Yeah, that's the summary. Hold on. What kind of one is that? Just to right? These are all the things from master I need to learn. David. Right? And the rules that we use there is way down on page, so to tell on page. And show up page. Right. Try to fill them out. See how many angles they can find. Two tangents, same chord. Look for the radius, look for the tangent. All right, let's see how much you're able to find. Right, from what I could see here, I'm using all the tangent rules. The tangent meeting the radius, so it means that this whole thing is 90. It means that this whole thing here is 90. Right? Here is 90, here is 90. I am also seeing that one chord, the chord FH, has two tangents. So it means that this triangle here, FH, is a isosceles. Okay? So it means that the angle here and the angle here equal. You okay with that? How much is that? That is 136 divided by 2. Yeah, 68. So here's 68, here's 68. And I'll also recognize that 68 plus this angle here is 90. Recognize that? Because OHE is 90 degrees. So if part is 68 and total is 90, I can minus some 90. And I will get 22 here, 22 here. You're seeing that? And if those two are 22, then how much is here? Triangle, right? All the angles in the triangle sum to 180. So 180 minus 44. How much is that? 136. Oh, yeah. I just worked out that. 136. Okay? So we kind of figured out a lot. If there's 136, we know here will be 136 and so on. So we kind of figured out a lot. We can figure out here if we need to, we can figure out here and so on. You'll recognize all these isosceles triangles in there? Yeah? Everybody okay with that? All right, so let's go to the question. Normally the question gives you the order to find it in, right? I am just trying to help you identify shapes, okay? Taking it off, right? Let's see what they ask us. Or they ask a lot. So they want us to get EHF. EHF is here, right? And the answer was 68. And what's the reason? The reason is HFE is what? Isosceles. Everybody okay with that? Right? FGH. That's this angle here. Oh, that's a nice one. I didn't see that. What's the rule that we're going to use to find that angle there? Think about it. Look back at the rules. FGH. I just want to highlight this shape for you. Triangle meets a tangent. You all seen rule number, what rule number is that? 7, 6? Which rule number is that? Huh? That's when the triangle meets the tangent. So yeah, so the angle here equal to the angle here, the alternate segment rule. You all seen that, Kayla? So here is 68. What about JHE? What's that angle? I'm gonna pick on somebody. I'm gonna pick on Faith. JHE. What angle is that? Next time out, they say premium. What angle is that? 90, yeah. Radius meets a tangent. 90 degrees. Okay? Radius meets tangent. And last one. J, G, H. Did I do that already? Oh, sorry. JGH. That's this whole angle here. Which rule is that? Killer. JGH. Which rule is that? What the angle looking like? It looking like what? JGH. It looks like a right angle, but what's the rule? So the answer is yes, it is 90. But what's the rule you're going to write? Angle in a semicircle, right? Because JH is a what? JH is a diameter. You're saying that, Rasnal? You're seeing that, right? Let's go again. Got the rules. So try this next one here on your own, and I want you to write the rules as I go along, right? Work it out, write the rule. Draw it in the book, right? In fact, you don't have to draw it in your book. Next one is Jan 2016. Jan 2016. Just do me a favor now. Write this down first. Write down what they ask you, and then I'll go to the shape. You can draw it if you want, or you can just write the answer. ADC, ACD, CAD, OEA. Online? Feel free to message your answers, right? Okay. Right? I'll put this shape up here and try to find them. But give a reason. Give a reason, right? Go ahead. Give a reason for each one, right? Try to identify the rule. Look at the shape and see what you can figure out. How much you got to do the rule, right? You don't have to do it. You can just put them out. Right? See how much you can get. You don't have to draw it. Just write the angle and write the reason. What you got? AOC and ADC, right? First one is ADC. Yeah. First one is ADC. Then the habits are right to the ruler on your place. Right? And after you figure out one, write it in the diagram. Right? So you have one less thing to work out. So look at the first one. What type of triangle is ADC? Right angle, right? Because AC is what? AC is diameter, right? So angle in a semicircle is 90. Here is 90. That's okay? So you have to write your rule. ACD now, right? ACD, the one, the angle here. How are we getting that? Probably we have to use that 72, right? What type of triangle is AOD form? Isosceles. So can we figure out here and here? Yeah? If O is 72, the angle at A is what? The angle at A is 180 minus 72 divided by 2. It's isosceles, right? So how much is that? That's 108, like 54. So here is 54, here is 54. Can we use that to now figure out here? Yeah? Look at the whole shape. ACD. Here is 90, here is 54. So here is minus that from 180. How much is that? 36. Sorry, 26. 36. Okay, yeah, 36. So the angle ACD is 36. All right? That's why the first thing I make it do sometimes is look at the shape and put in what you could find without working out the without looking out for the axiom. Right? Sometimes it helps you. What about CAD? Figure out CAD already, right? CAD is oh wait, so there's a different way to work it out. So CAD is here, which is 54. See that? CAD, we work it out already. CAD was 54. What about OEA? OEA, that's right here. Think about it. I'll give you a minute. What will OEA be? Try to figure out OAE first. OAE is how much? OAE is a tangent and a radius, so the angle here is 90. So it means that this angle here is 90 minus 72, which is 80. Right? Sometimes they do have reasoning, right? So sometimes you can just do sheer calculations. All right? So in order for you to get OEA, you have to tell them OAE is 90 degrees because a tangent means a radius, and then show them a calculation. Right? 90 minus 72 will give you the remaining angle. Okay? Write it down. Let's go again. How much you all got out of the 4? Anybody get all? Some people get all. I saw some people get 1 and thing. Let's go again. This one looking hard. Write down the three first. You want to get BOA, you want to get EOD, and you want to get BFE. All right. Go to the shape. Go to the shape and try to work it out now. If you want to ignore what they asked you to find, go ahead and ignore it. Try to see what you could find. Right? So the first thing I would look for is what's that big shape. And I would look for all the radii. And I would look for where the tangents and the radii are. Okay? So look for what the overall big shape is. Look for the radii, or three tangent, and apply the one tangent. Then you can go back and try to answer what they asked. Right? One of the trickiest rules is rule number 6, right? When a triangle meets a tangent. Right? So look for that, right? About when the triangle meets tangent. See if you can figure out where that 42 also applies. Right? See if you can figure out where that 42 will be equal to, right? Help you out a lot in figuring out the rest. Right? So from the shape, see how much you can figure out without. Right? Look for your radii. Right? See what the radii forming. Look for the tangent meeting the radii. Right? There are lots of things that you can see, right? Look for the triangle meeting tangent. Check and see if it's seen a sighted quadrilateral. Right? Look for the rules. Look one more after it. Let me do the last one. Let's see if we can get it out. Right, this might be the last one, right? So let's see if we get it out. Right, BOE should be simple, right? I want you to get that one, BOE. Try and figure out what type of triangle is that. And you'll figure out BOE. Right, OED, tricky. But you can figure out BED and then figure out OED. Hurry up, come on. Let me get them. Don't take your time, ready? And then BFE here. Let me get that one. So far. Ready, read some. Look at it. Just to help you a bit, there's a radii, right? Those are two radii there. So what type of triangle is that? Isosceles, nice. So you should figure out here, and then you'll figure out here, right? You're seeing this 42 here. Where again is 42? Where again is 42? What is shape good? Tangent meeting this big triangle. You're seeing that? So you should be able to figure out where the alternate angle is. Right? And then you should see a radius meeting a tangent. All right? 2 minutes again. 2 minutes again, then we correct. Then we move to vectors. All right, let's see if we got it. All right, so angle BEO, that'll be 20 as well. And because it's isosceles triangle, here will be 180 minus 180 minus that fella there. Minus 40, which is 140, right? What they asked us for, BOE, so this is 140 isosceles triangle. Oh, you're seeing this angle here? Angle at the center is twice the angle at the circumference. So here is 70. That will help us find part 3. OED now, OED. They want this small angle here. But what is this big angle here? That big angle is 42, right? Alternate segment rule, right? So it means here is 22. All right? So we figured out OED, 22, alternate segment rule, minus 20. And we're good to go. BFE is what? BFE is right here. And that big shape, BFED is a what? Cyclic quadrilateral. So that'll be 180 minus 70, which is 110. Everybody okay with that? All right, so again, you have to learn the rules. By learning the rules, the shapes will pop up, right? Once the shape pop up, you'll be able to apply it and work it out. Next, vectors. All right, let's take a look at vectors. Right, if you look at the more recent years, you'll see vectors get a little bit easier, shorter and easier, right? They don't ask for collinear and some of those things again. All right. So let's start with vectors. Let's run through this notes. Right. So a vector, basically what we do, we can take a point. So if I say plot the point 35 and I want to turn it into a vector, all I have to do is draw that point relative to the origin, and I will get the position vector. So the position vector OP is equal to, all I have to do is write this as a vector, 3, 5. Right? If I were to change from O to P, if I were to change P to O, all that will happen is that the signs will change. So I'll get minus 3 minus 5. That's okay? So remember, when you flip the sign, when you flip the direction, change the signs. Right? Magnitude of a vector is the square root of the x value squared plus the y value squared. How do we add and subtract vectors? Real easy. Right? If I gave you 2 vectors, as you'll see here, if I ask you to add 2 vectors, all you're doing is you're adding the x values, adding the y values. Right? If you're subtracting, subtract the x values, subtract the y values, and you get your answer. Real easy, right? But starts to get a little trickier. Whenever you have to multiply a vector by a scalar now, let's say you had to multiply 3 by 5 minus 1. Right? You multiply the 3 by the 5 and the 3 by the minus 1. So you'll end up with 15 minus 3. That's okay? That's the way you multiply by a scalar. If you have to multiply 2 vectors, it's no longer a vector. It's called a scalar. So if you have to multiply 2, 1 by 4, 3, you multiply the x values and add it to the product of the y values. 8 plus 3 is 11. Right? Notice it's no longer a vector, it's a scalar value. Okay? It's no longer a vector like this. So whenever you're multiplying 2 vectors, you'll get a scalar. Right. Now for the slightly challenging part. Suppose I gave you a triangle, and along the triangle, I want you to find unknown things, right? So, let me just change up. Let me just create a new example. Suppose I gave you something like this. I gave you O, A, and B. And I said that OA is 2A and OB is 3B, right? How do we find that unknown vector A to B? To find the unknown vector A to B, what we do is we try to find an alternate path that will take us from A to B. And you use the shape given. So you're going O to A, sorry, A to O, O to B, right? So you find the alternate route from A to B. That will be A to O, and then we're going to add it to O to B. That's okay? You'll always recognize, right, that this letter is on the outside here, this letter is on the outside here. And you have some common letter in the middle. All right? What is A to O? Based on what we see in here, it will be minus 2A. Why is it minus? Against the arrow. And OB will be 3B. That's okay? Let's complicate it further. Suppose now I introduce some random point, right? Suppose I introduce a point C. And I said, here's what? C is the midpoint of AB. Right? C is the midpoint of AB. So up half here and up half here. Right? So if C is the midpoint of AB, then AC is equal to half of AB. All okay with that? C is the middle, right? So therefore, AC has to be half of AB. So suppose I ask the question, what is OC? Then, for me to find OC, I have to find the alternate path the arrow from O to C. That's okay? Look at the triangle. What's the alternate path from O to C? I can start at O, and I go into A, then I'm going to C. So the answer will be O to A plus A to C. Do I know what OA is? Yes. OA is already 2A. And AC is what? AC is a half of AB. AB is minus 2A plus 3B. And you work it out after that. Are you okay with that? So whenever you have to find an alternate vector, the rule I want you to remember is find the alternate path along the triangle from where you start to where you finish. Okay? First letter to the last letter. All right? Find the alternate path. Next, we have two rules to remember. Parallel vectors. How do I show two vectors are parallel? Well, if one vector is A, the next will be 2A. Parallel vectors are multiples of each other. Yeah? Suppose I give you 4, 6, and I give you 8, 12. Are they multiples of each other? Yeah? Yep. So yes. So therefore, those two vectors are parallel. Suppose I were to change it to a minus sign here. Are they parallel? Are they multiples of each other? No. Right? So they are not parallel. And now for the hardest thing, collinear. Collinear basically means that we're trying to show that 3 points lie in a straight line. Okay? How do we show 3 points lie in a straight line? Well, first thing we need to do, find AB, find PC, and show it parallel. Okay? So we have to show that AB is parallel to PC. How are we doing that? Show that they are multiples of each other. That's okay? And last step. Since we know AB and we know PC, we have to find AC. Find the whole line. Add them and see if we get them to be the same. All right? So those are the rules of collinear. Are you okay with that? So if I ask you, if you let us change now and I say show that PQR, show that PQR collinear. Step number 1, find PQ. Step number 2, find QR. Step number 3, show that they are parallel. That's okay? And step number 4 is to find PR and then add up 2 of them and show they equal. All right? So you have to learn all those rules. Okay? And good? Vectors done. Vectors done. Let's head to the past papers. Right? I don't want to give you questions that are too hard because, yeah, after this, after vectors. I miss average, sorry. Hello, fresh, so. Fresh. You are fresh. Nice pen come back, man. Let me see if I can move this pen here. Right, let's check out the vectors matrices, fellas, here. This one looking easy, boy? This might be a good startup here. Right, when you do a vector question, I know you will have your past paper with it there, but every time you do a vector question, you have to draw it. Have to. Without a proper diagram, you're not gonna get this out. Go ahead, draw a diagram, put in the important things. Right, we're gonna do this first one together. Right? Copy the diagram down, put the important things on your diagram, and then we're going to try to work it out. Right, so a diagram, and see if we can just put what they asked, right? They said PR is 3OP. QS is 3OQ. Try to put that in your diagram. And we start to work it out. Ready? Let us see what we can put in the diagram first, right? So the question said, well, P to R is 3OP. So I write in, I join an arrow P to R, and I write in 3OP. You know, multiply it out because they gave us that afterwards, right? They said QS is 3OQ. So I write in 3OQ here. Nice. What is OS? You all seen the whole line OS? So OS is how much? 4OQ, right? So it's 4OQ. So it's 4 by, what is OQ? They gave us OQ. OQ is 50. So that'll be 20. So we know OS. Everybody okay with that? You'll follow what I did? Yeah? You sure? Now PQ. Is there a line connecting P and Q? See that? Pardon? How I got 4 because I have 1 and I have 3. And the OS is the whole line. That's okay? OS is the whole line. Is there a line connecting P and Q? No. So we should draw a line connecting P and Q. How do I find PQ now? PQ is what? Peter O water Q. Yeah? Nice. Sure? So that's P to O plus O to Q. What is P to O, Kelly? P to O is what? P to O? What's good? And we have O, right, but is that correct? Minus, because it's P to O, right? So it's minus 4, minus 3. And OQ is 50. So the answer is 1 minus 3. Everybody okay with that? Jacob, we had to find RS. What do I do? First thing first. Before that, draw a line R to S, right? Draw a line R to S. And based on the diagram now, RS is what? Yeah, no, tell me the ROOS. And anybody who feel not adventurous, you can also go R to P, P to Q, Q to S. All right? It doesn't matter if it's a triangle or not. It's the alternate route from one to the next. Right? So RS is R to O plus O to S. Okay? Find RO. I don't think we have RO as yet. Find RO and OS. Work it out quick. Right? So remember, we didn't really work out OR, right? We worked out OS. OR is how much, Jared? OR is how much? Yeah. Right. So OR is 4OP. All right. That whole line is 4OP, right? So that's 4 by 4, 3, which is 16, 12. Right? So remember, we have to get that whole line there, right? We didn't work out that. So RO is how much? RO is minus 16 minus 12. And OS, we worked it out and got 20, 0. So the answer I have here is 4 minus 12. Right? Question. Sama, how PQ and RS related? Yeah, how they related? Look at the points. How are they related? Same? Now, looking for something else. What's the answer, Soraya? Collinear? Yeah, yeah. Parallel, right? They are parallel. PQ and RS are parallel. How come? And what else? These values are multiples of each other. If you were to multiply this by 4, you will get this. That's okay? Yeah? So they are multiples of each other, so therefore they are parallel. PQ, but sorry, RS is 4 times PQ. Let's go again. Try and plot this one. Plot it, set it up. This one has no diagram. You have to come with a diagram, right? If you want to actually plot it because you have points, nothing wrong with that. Okay? Last one, then I'll give you up. You all don't need a break. We normally start half at 11, eh? So you normally get tired around 11. We're real time, man. Plot the points and then draw the vectors back to the origin. Right? So that's, you could actually go and plot it, right? 0, 9, that's right here. Here's O, and here's C. Plot minus 2, 8. Minus 2, 8 is about here, so that's A. Draw a line, draw your arrow, and plot B. B is 4, 2. 4, 2 is somewhere here. All right? So your diagram looks something like that. Copy it down. And try and work it out. All right. Let's see what you came up with. OB. OB real easy. All you have to do is write the point like a vector. That's all. 4, 2. Right? AB, draw a line from A to B. Piano. A to B is what? No, tell me the root. Tell me the root. How do I find AB? Alternate route from A to B along the triangle. So that's A to right? A to O, and then O to B. What is A to O? A to O will be positive 2 minus 8. Don't forget to change the signs, huh? Don't forget to change the signs. And OB is 4, 2. All right, so I got 6, 6. Anybody else got that? 6, 6. Right, do OM. M is where? 6 minus 6. Oh, sorry. 6 minus 6. M is where do I put M? Sierra. Where do I put M? In the middle of AB. Very good. How do I find OM? Draw a line from? Draw a line from O to M. Please remember, M is the middle, so I write in a half and a half. Okay? How do I find OM? Bradley, OM is what? O to? The question is the question. OM, how do we find OM? O to A, right? And then A to M. Nice. O to A is what? O to A is minus 2, 8. But the problem is AM. AM is what? AM is half AB. So a half of 6 minus 6. So that'll be minus 2, 8 plus 3 minus 3. So I got, I got 1, 5. Yeah? Raznal, take it out. 1, 5. Got wrong. She get the same thing. If you go OB, BM, but remember, if you go B to M, it will be minus 6, positive 6. So you have to change the sign because the arrow, you're going against the arrow. How do we show AC parallel to OB? Jaden, how are we doing now? Right. So we had to get AC, right? Wait, where is C? Oh, look it up here. AC is quite up here. I know the diagram is not the best, but anybody can help. Well, not anybody. I'll pick on somebody. Richard, AC. How do we go from A to C? Richard? It starts at E. Always start at the first letter. Right? You can do all that, or you can even shorter. Yeah. Right, Richard? Piano help you there. A to O, O to C. Got that? Richard? Right, A to O is what? A to O is positive 2 minus 8. And O to C is what? What's OC, Diego? OC is what? The X value is 0 and the Y value is 9. So we end up with 2. We end up with 2, 1. In top right hand corner there, right? 2, 1. Sorry, in bottom, middle, right hand side there. All right, so I got AC to be 2-1, and we already have OB to be 4-2. Are they parallel? Are they parallel? Are they parallel, Faith? Huh? Why? Because they are multiples of each other. All right? Right? You go again? All right, take a 10-minute break now. 10 minutes, huh? Huh? Yeah, but it closed my hand up, man. Everything done. That water, and it probably have Bigfoot. Right, yeah, take a little break. You have 10 minutes, exactly 10 minutes. And then we could probably do matrices. Or we could do our next one of this. All right, let's cover the matrices. On those who don't want a break, you can probably do our next one. If you don't want a break, you could do this and I'll check it for you. Huh? Look, June 2013. It's in the topic by topic I sent you. You do have it by topic? It's in the group. I added to the group already. Take a Let's try to correct this one here, right? To your diagram, you just go and put in some of the things that they gave you, right? Right. They said P is the midpoint, Q is the midpoint, so we know it already. Here's half and here's half. Right? OA is 2A, right? And OB is 2B. Or not 2B. All right, so here's A. Put in the arrow. Here's A. The reason I put it like that because P is the middle, right? Here is Q is the midpoint of AB, right? What did they say? And OB was 2B. And here was 2B. So now they want us to find AB. Well, all we have to do is get the alternate root from A to B. So that'll be A to O plus O to B. So based on what we have here, that'll be A to O, that'll be minus 2A, O to B, 2B. Right? Now P to Q, draw a line P to Q. Draw a line P to Q. Remember, we have A, B, right? So here will be half and here will be half because Q is the midpoint. So how do we get PQ? PQ will be P to A plus A to Q. Okay? What is P to A? P to A is small a. A to Q is 1/2 AB. So it'll be 1/2 AB, right? So AB is remember AB is minus 2A plus 2B. So when you add it up, you'll get A minus A plus B. So I got B alone as the answer. Anybody got that? P to A is A. Next one is half of that. Anybody got that? B? Yeah, B. So we know what PQ is. We know that PQ is B and OB is 2B. Are they? What is the relationship between two of them? They are what? Parallel. They are parallel, right? Why are they parallel? Because they are multiples of each other. That's okay? You okay with that? All right, good. Copy it down. Let's go again. Let's go to matrices now. What do you guys set up? I'm able to run on you know? All right, so let's go to matrices now. Somebody writing so? All right, so let's take a look at matrices, a little summary there. You have everything you need. The hardest thing in matrices is basically being able to multiply two matrices, right? All right, let's start. Where is the thing? All right, matrices. Right, I'll send you. I did 3 new videos on this. I'll send in the group. You can always look it over. Ready? Who was next to you there? Somebody next to you? All right. So let's start with matrices, right? So what is a matrix? A matrix is a set of rows and columns, right? Here we have an example of a matrix with 2 rows and 2 columns. So it's a 2 by 2 matrix. Everybody okay with that? Right? How you just get the name? Number of rows by number of columns. So for example here, how many rows this matrix has? Rows. 3 rows. Rows are horizontal, right? Columns are vertical. So you have 3 rows, 2, 1, and 3, and 1 column. So this matrix is a 3 by 1. All right, always rows by column. Right? We have a column matrix, a square matrix, and the most important, well, a very important square matrix called the identity matrix, 1 0 0 0 1. You have a row matrix, null matrix. How do we add matrices? They have to be the same. They have to be the same size, right? And you add the similar elements. Can we add A and B? Can we add A and B? No, right? A is a 2 by 1, B is a 1 by 2. Can we add A and C? Yes. How do we add? Add the same elements, right? Add 1 and 4, 2 and 3. That's okay? How do we subtract? Same thing. 1 minus 4, 2 minus 3. Right here, you'll see an example for each one. We cannot add them, right? Because they are, what's the word again? A and B are not what? Huh? Somebody say comfortable? Conformable, right? That's right. It looks like comfortable, right? But A and B are not conformable. All right, yes, so we added the same values, right? Add the 1 and the 4, add the 2 and 3. Scalar, how do we multiply by a scalar? Just as before, you multiply k by every single one of the values. Just like here, multiply 2 by each one of the values there. 2 by 2, 2 by minus 3, 2 by 4, 2 by 5. And you get this. All right? Good. That's not the problem. The problem is multiplying 2 matrices, right? Whenever you multiply 2 matrices, those two rules have to hold, right? The first rule is the number of columns in the first matrix has to be equal to the number of rows in the second matrix. That's okay? After, if they're not equal, you can't multiply them. And if they are equal, then the answer or the product is an A by C matrix. That's okay? Now, how do we multiply? Well, in order to multiply, we have to remember this rule here. Rows in matrix 1 by columns in matrix 2. You always multiply row by column. Rows in matrix 1 by all the columns in matrix 2. Row in matrix 1 by all the columns, right? Remember that. Let's take a look at an example. Right, I'll try and fit it in here first, right? Right, face to face, if you're not seeing it, I'll come here and do it. Actually, even if I do it there, it wouldn't show up on YouTube. I'm gonna just do one here first. And then I will come on the board and just do one. Right. Let's say we have to multiply these two matrices. First thing you do, check and make sure they're conformable, right? So a 2 by 2 by a 2 by 2. These two numbers equal? Yes. So your answer will be a 2 by 2. Right? So how do we multiply? Because I know the answer is a 2 by 2, I am setting it up one time. 2 rows, 2 columns. So I know what to expect, right? I'm supposed to get 4 values. Right, how do we multiply? Remember the golden rule, Faith. Rows by column. Rows in matrix 1 by column in matrix 2. Okay? So you're multiplying this row by all the columns. Okay? And then when you finish with that row, you multiply the next row by all the columns. You will always notice when you're multiplying a row by a column, you have exactly the same number of elements in the row as the number of elements in column. That's okay? If they're not equal, you're doing something wrong. All right? So let's start. I will try and do each one a different color, so hopefully it might show up, right? So I'm multiplying this row by this column. So I'm multiplying 2 by 2, and I'm adding it to minus 1 by 5. That's okay? Faith, you can do this properly. I'm bringing anybody to do this one, huh? Jamie on. I'll pay attention, please. All right? You all okay with that? So I'll multiply the first row by the first column. All right? Now, we still have a next column to multiply. So I'm going to multiply this row by this column. So the first row by all columns. Now I'm multiplying 2 by minus 3 plus minus 1 by minus 2. Okay, so I multiply this value by this value by this value. Now I am done with the first row because the first row multiplied all the columns. All right, so I'm done with the first row. I'm going to go to the next row now. I'm going to multiply this row by this column. So I'm going to multiply 4 by 2 and add it to 6 by 5. And then last row now, sorry, last column. So I'm going to multiply this row now by this column. So it's 4 by minus 3 plus 6 by minus 2. So you're multiplying and adding, right? You're multiplying 4 by minus 3, added to 6 by minus 2. And you're done. Let's see what you will get. 4 minus 5 minus 1 minus 6 plus 2 minus 4. 8 plus 30, 38 minus 12 minus 12 minus 24. That's okay? That's the way we multiply all the time. Row by column, row by column. All right? Let's try a next 2 by 2, and then we'll try a 2 by 2 by 2 by 1. If you want to copy it down, copy it down. It's up to you. I'm going to give you our next one to try this. All right? All right, let's go again. Try this 2 by 2. 2, 5 minus 3, 4 by 1, 6, 2 minus 1. Multiply those two. Let's see what you get. All right, let's see what you got. Right, so 2 by 1, so you're multiplying this row by this column. 2 by 1 is 2, 5 by 2, 10. And then this row by this column, 2 by 6 is 12, 5 by minus 1 is minus 5. Done with the first row. Next, minus 3 by 1, right? 4 by 2. Then this row, this column, minus 3 by 6, 4 by minus 1. So we ended up with 12, 7, 5, minus 22. You got that? Yeah? Right? Let's go again. So I'm gonna give you a 2 by 2, but 2 by 1. All right? Multiply it from and then we could go to the other little thing. Multiply those two. Multiply those two. Same principle, row, all the columns. Next row, all the columns. Okay? Right? So check and make sure a 2 by 2 by a 2 by 1. These two answers are the same. So your answer will be a 2 by 1. So you're going to get 2 rows, 1 column. Okay? That's what your answer will look like. How do we multiply? Row by column. 2 by minus 2, 5 by minus 3. Right? Then row by column again. 3 by minus 2, 2 by minus 3. So I got minus 19, minus 12. Okay? Are you okay with that?
So you can repeat that last one more time?
What's that? Which part?
The last thing I say. You're talking about the minus 19 and 12 minus 12.
I can't remember. But all I was saying is that check and make sure if you can multiply and then check for the answer. Right? You multiply this row by this column, this row by this column. All right? I think that's what I said. All right? So the next thing that we have to look at now is we have to look at how to find determinant. Determinant really easy. You multiply A by D, B by C, and minus them. Okay? That's the determinant, right? You kind of cross and then you minus. A by D minus B by C. Remember this rule here, right? Remember that if the determinant, oh, look at it. If the determinant is 0, matrix is singular. If it's not 0, then it's non-singular. Okay? Remember that, right? If the determinant is said to be singular, then that determinant value is 0. Right? How do we find the inverse? Really easy. 1 over the determinant by the adjoint. How do you get the adjoint? Switch around A and D and change the sign of B and C. Watch this here. Let's try a small example. if I gave you the matrix A, right? A is 2, 3, 4, 1. Find the determinant. The determinant is 2 by 3, 6, minus 4 by 1. So the determinant is 6 minus 4, which is 2. Now, how do we get the inverse? The inverse is 1 over the determinant by the adjoint. How you find the adjoint? Switch around the 2 and the 3 and put a negative sign by the 4 and the 1. That's okay? And that's it. If you want, you can multiply everything by a half after if you want, but it looks a little more complicated. So it's easier to work with it like this. Leave the half on the outside. All right? So that's the way you find the inverse. Find the determinant, 1 over the determinant, and then multiply it by the adjoint. Right? So that's the way you find the inverse. And last thing, how do we solve simultaneously? Right? You have these 3 steps to remember. Right? Write this down. Write in matrix form. Find the inverse. Multiply by B. Right? Those are the 3 steps to solve simultaneously. Write in matrix form, A inverse, find the inverse of A, and then multiply the A inverse by B. Once you do that, that will be how to solve simultaneously. All right, what's the example here? First thing I did, I took this and I put it in matrix form. Right? If you have 2x plus y, 3x minus 2y, the matrix form will be positive 2, positive 1, positive 3, minus 2. Okay? Take all the coefficients, right? So I have A, I have x, and I have b. Find the inverse. I found the inverse here, right? And then I'm going to multiply the inverse by b. Okay, how you multiply? Row by column, row by column. And you will end up with this here. And then you multiply everything by 1 on minus 1/7, and you get this. That's okay? So you have to remember those steps. Find the inverse. After you find the inverse, multiply it by b. Right? B is 3/1. All right. So those are the things you need to know. Of course, we have one more thing to do with matrices. That's the transformation matrices, right? So watch this here. There is no way to export. What is happening there? A disconnect? Right. If you look here, you have to learn these matrices. Right? These are the matrices for rotation. Right? These are the matrices for reflection. All right? You can't escape, you have to learn it. All right? The only shortcut you could probably do is this. Right? You could learn the first four here, the first few here. Right? Reflection, you will have to know them. So you have to know these matrices. Scaling is enlargement, right? That's the enlargement matrix. So for example, right? For example, if you have a scaling of factor 2, that'll be a matrix, right? If you want to rotate counterclockwise 90 degrees, put 90 in here, and you'll get the matrix. Translation, you can just write it like this as well, right? Right? Write the X translation, Y translation. But the reflection, you have to learn them. Reflection in the X-axis, minus here. Reflection in the Y, minus here. Reflection about the origin, minus sign here and here. Reflection about XY, that's the matrix here. All right? So you can't escape without without knowing them, right? Just do me a favor now. Screenshot them or write them down. Anyone you want. Take a picture and make sure you have it, right? I don't think this on the summer. I didn't add it. I'll add it in for next year. Yeah. Zoom out a little bit. Yeah, this killing a little block. I can't move that. By the way, to take the bottom, right? The bottom not on your syllabus. The last 3 not on your syllabus, right? Only the first 9. All right, so let's jump into some matrices, right? Play it back. All right. Go on, by the way. Go on. Go ahead, have fun. Do your thing here. It'll be as long as it's an exam, but I'm giving you this one because I want you to practice everything. Copy it down, do it. I'm giving you 10 minutes for this one, right? Or the same part 2, the same, just write it. I want you to solve it. Right? Solve part. So that's right. Right up. Copy it up, right up. Or just do question. That's the question. Anybody here not on the form 5 group? No. here. Hello? All right. Let's see how this went. Show by multiplying A, B, and B is not equal to BA. So the first thing I'll do is find AB. So 3 by 4, that's 12. 12 plus 6. Then 3 by 0, 2 by minus that. Right? 5 by 4, that's 20. 4 by 3, that's 12. Then you'll get 0 minus 4. So I have 18 minus 2, 32 minus 4. You're gonna have AB. Let's check out BA one time. BA is the other way around, right? So that'll be rho by, say, multiplying 4, 0, 3 minus 1 by 8. So that's 4 by 3, that's 12 plus 0. Then you'll get 8 plus 0. Then you shall get 9 minus 5, and you'll get 6 minus 4. So you're getting 12, 8, 4, 2, which is not the same. So therefore, multiplication is not commutative. Okay? They are not the same values. Next, find the inverse of A. Inverse of A is equal to 1 over the determinant of A. The determinant of A is 3 by 4 is 12 minus 10. So the determinant is 2. And then the adjoint is what? Huh? By here. Right? And the adjoint is what? Switch around the 4 and the 3, put a minus by the 2 and the 5. Okay? That is your inverse. The question said to write down the matrix of A by A inverse. So you don't have to work it out. What's the matrix you will get? A by A inverse is what? Right, 1, 0, 0, 1. Right? So the answer is, I'll put it right here for you. 1, 0, 0, 1. Okay? Every time you multiply A by A inverse, you will get 1, 0, 0, 1. That is called the identity matrix. And last thing, write the following payout simultaneous as a matrix. So that'll be 3, 2, 5, 4. XY is equal to 1, 5. Right? What will this solution be? How do you obtain this solution? Right, look back at step 3. How do you obtain the solution for XY? Yeah. Malachi, what else? Huh? Yeah. A inverse by B. And we already have A inverse. A half 4 minus 2 minus 5, 3. And you're multiplying that by B, which is 1, 5. Okay? I know the question did not ask for it, but work it out for me now, please. Multiply it out, and what you get for X and Y. Page, you work it out? Let me see. You actually work it out. Multiply it out, tell me what you get. Ravina again, sure. Oh yeah, multiply it out. Leave the half for last, right? Multiply the two matrices first and then multiply it by a half. right? It makes it easier, right? Right? Let's see what you got. So you're multiplying a half by 4 by 1 is 4, minus 2 by 5 is minus 10. Minus 5 by 1 is minus 5, 3 by 5 is 15. So it's a half by minus 6, 10. A half of minus 6 minus 3, half of 10 is 5. Okay, so you get minus 3, 5. Okay, nice. That's a matrix question. Next one. Next one. Let's see if we have one here with the transformations in it. Pew, pew, pew. Pew, pew. All right, let me do one here. Let's do one here. All right, so how we getting C and D? So watch this here. Right, you should be experts in transformations now. So take a look at the points there. See, you're going good all the time until you see the tracks in here. I'll send in front here. Right. Look at it there. 2, 3 became 2 minus 3. What does that look like? Which value is negative? Which value became negative? The y value, right? Right? Based on transformations, when the y value becomes negative, what is that? When the y value becomes negative, is a reflection in the x-axis. So it's a reflect in the x. That's it, right? Anybody remembers what's the matrix that will do that for you? Go to your matrices now. Sorry? 1, 0, 0. 1? No. Minus 1. Right? That's it. That's how easy it is. Everybody okay with that? So that's one way you can do it. Right? One way you can do it is by learning the matrices off. And next way you can do it is like this. Multiply and solve simultaneously. I know you all like that method more. Here's what you can do. You can take the matrix T. In order to get image, right? To get image, you can multiply T by P and you'll get the image. So multiply C0, 0D by P. P is 2, 3. And you're supposed to get 2 minus 3. Right? Whenever you multiply a transformation by the point, you're supposed to get the image. Notice, don't write it horizontally. Write it like a column matrix. So you'll end up with 2 by C by 2 is equal to 2. So that means C is 1. And then you will multiply 0 by 2 is 0. 3D is minus 3. So D is minus 1. That's okay? That's the next way to do it if you don't remember the actual matrix. All right? But by exam time, you'll be so sharp, you'll watch it and just write down the answer. Easy maths. All right? Next one. Determine the image minus 5, 4 of minus 5, 4 under the transformation T. What do you do here? What do you do? Multiply 1, 0, 0 minus 1 by minus 5, 4. What you'll get? Do it mentally. What you'll get? Minus 5, minus 4. Everybody okay with that? Describe fully the transformation. What's the transformation? Transformation is a reflection in the x-axis, right? Reflection in the x-axis. And last part, find the matrix that maps Q to P. How are we doing that? Map Q to P. How you will map Q to P? You're mapping it back this way. What are you gonna do? So here's what you have, right? P was here, now Q is here. But they want to go the other way around. What would the answer be? You have to know your transformations, right? How are you going Q back to P? Jamian? Are you reflecting the X? Same thing, right? Same thing. And? Yeah? Well, I'm not sure. So, all right, here is 2, 3, right? When you reflect in the x-axis, what would it become? It will become 2 minus 3, right? So how do you go from 2 minus 3 back to 2, 3? Same reflection, right? Same reflection. All right. Okay. Right. I know all the kind of tools, but that's good. Let's go again. Let's go again. All right. Take up. Oh, no. This one, man. This one easy. Just try one and then take a little break, and then we'll do some area and some volume and thing. Easy stuff, right? Or some multiple choice. Anything I want to do. All right? Go ahead. Do this one. Make sure I have fun, right? Try that fast. Malachi, come on, I'll put it for you. Huh? Oh, you do. Oh, let's see. Oh, wait all here. I forgot to do sets. So we're going to do sets multiple choice. All right? We're going to do sets multiple choice. Okay? Yeah, take it off. Good question. Oh, yeah. Yes. All right. I see you found the inverse. The inverse is 8 minus, sorry, the determinant is 12 minus 10, that's 2 again. Why does it look so familiar? Minus 5 minus. Anyway, right. So let's see if we get the hang of the transformation question. By the way, I don't want to be the bearer of bad news, but sometimes you see this in paper 3. Right? So you can't run from it. You see, like how normally in June, you're just getting 2 papers. There are topics that you could run away from. But between paper 1, 2, and 3, every single thing is there. So there's no running from topics you don't like. If you don't see it in a paper 1 and 2, high chance it's going to be in a paper 3. All right? All right, so they said 7, 2 map to 2 minus 7, minus 5, 4 map to 4, 5. Anybody recognize it before we work it out? Anybody recognize it? No, nobody recognize it. All right. So it's 0, A, B, 0, multiplied by 7, 2, giving you 2 minus 7. So 0 by 7 is 0, A by 2 is 2, A is 2. So it means that A is equal to 1. That's okay? Multiply it out. You'll get 7B is equal to minus 7. I got B to be minus 1. So the answer I have is 0, 1, minus 1, 0. The problem now is that you will have to know the transformations. So what is this one? A 90 degrees rotation, anti-clockwise. 90 degrees rotation, anti-clockwise. Most of these assume 0, 0 as center. All okay with that? Yeah? So you have to learn the matrix, the picture that you take, you have to learn that. Right? Well, please do work between now and next week. I know Christmas is Monday and Tuesday. Christmas, but please do some work. You'll be surprised how you'll forget all of this. Right? Next week, Saturday, Paul, do remember this? I'll just fall in a room to watch videos. Right? Make sure you go over these things. If you want and you're not writing, Jan, you want to come Saturday, it's up to you. That Saturday would allow it. That's 2 topics that you get trouble with. It will be structured a little bit different. Right? I'll send you a WhatsApp and explain to you how it will work. So if you're not writing, Jan, you can stay in one room and just do one topic alone. So you know you do like tricks, you just sit down and you do tricks alone. All right? Whole day. You can go to the next topic and that's it. All right? Okay. One topic I didn't get to do was sets. All right? So take 5 minutes and let's take a look at sets. All right, 7 minutes. Okay? 7 minutes and sets is no longer paper 2, it's only paper 1 all year. I am starting one time. I'm not waiting to come upstairs. I am starting 11:30 to do sets. 7 minutes. Right, you now reach 2.5 hours. That's how long your exam is. You gotta get used to concentrating this long. 2 hours and 40 minutes, sorry. So you still have 10 minutes to go. All right. The door. Close it, please. Why you going inside there? All right, so let's take a look at sets. And we'll do a couple multiple choice and that's it, right? Right, sets, you will not see sets in your paper twos, you will see sets in your multiple choice, right? And you have to be able to work them out. Let's take a look at all these symbols and then what each symbol represents. Right? First thing, how do we represent a set with a little curly bracket and commas in between? Here we have a set, three sets, one with two elements, one with three elements, one with two elements. Okay? In this section, you're looking for what both sets have in common. If you look at this set on top, they both have, in A and B, they both have three in common. That's okay? Union, you're going to list all the elements, but don't repeat anything. So union, A union B is listed 1, 2, 3, 3, 9. Although you have 2 3s, you only write in 3 1s. All right? Proper subset, right? Proper subset, you're looking for which elements totally belong to our next, right? So if you look closely, C is a proper subset of P. You're seeing that? All the elements in C is 3 and 9. All the elements in C inside P. All the elements here inside here. Right? That's subset. Right? You have superset, don't worry with that. Element. This is the symbol for element. Not an element, you draw a line through it. Next, for Venn diagram. Venn diagrams are what you use to show sets, right? You need to remember that the number in union is the number in A plus number in B minus the number in intersection. Right? If you look at set notation here, if you look at the set notation shaded here, A intersect B is this middle region here. Union is everything here. A complement. Complement means everything outside the set, right? A complement, everything outside the set. A intersect B complement. This is called what? Anybody remember the worded version for that? What's the worded version for that part there? A only. Right? It's called A only. This one, B only. Right? This one here, right? A union B complement here, A complement union B here. The intersection between both of them, and here is everything outside A union B. All right? So you have to know these Venn diagrams and what they represent. The last one is everything outside A union B. Okay? And the second to last one is A intersect B complement. Everything outside the complement. All right? So you need to know those little things. Just please remember when they say A only, that's what they're talking about. Right? A is the whole thing, but A only is that shaded part. All right? Let's take a look at some questions and we could wrap up there unless you want to do some area and volume. All right, let's start here. Which of the following set is equivalent? Equivalent simply means it must be the same size. A, B, C, or D? C. Right? C is the same size. Number 2, what's the shaded region here? What's the shaded region here? The answer is apple. Everything outside P. See that? Everything outside P is shaded. Let's go again. Nice one here. Sometimes you will have some calculations to do. What is X union Y? Remember I gave you this little formula just now? X union Y is the number in X plus the number in Y minus the number in X intersect Y. Okay, you have to learn those little things, right? I gave it to you in the little summary. Here's 7 plus 5 minus 3. Right? That is B. Bradley, you okay with that? Try this next one here. And what was the answer? That's not. What's the answer here? A, B, C, or D? C? Wrong. Why? Why it's wrong? See if we can figure out why it's wrong. Because the minus 2 and 4 included. Right? This symbol means the minus 2 and this symbol means the minus 2 and the 4 included. So the answer is dog. Yeah? Try this next one. What's the answer here? Pew, pew, pew. What's the answer here? Apple. Nice. Do your thing here. What do you all think? What is inside the shaded region? Factors of 6 and factors of 4. See? Sure. Answer boy. Right? They both have 1 and 2 in common. Okay? Factors, right? Not multiples. Nice fella here. Number 7. Think about this one. "17 study music, 20 study art. What is the least number of students who are studying both? Both of them. Use the formula I gave you before, right? So 32 is the union. So 17 plus 20 minus both. Right? Remember I gave you this formula. A union B is number in A plus number in B minus intersect. Right? Work it out and you will get X to be how much? X to be 5. B. Okay? So you have to be able to do that. Right? Please remember this formula here, right? Kayla, remember this formula here. If you're distracting you, I'm going to sit down here from Malachi. Check this next one here. What's the number of elements in A complement? A complement, everything outside A, right? What's the number of elements in A complement? Saraya, what you got there? So you got right 3. B. B. Right? So the answer, boy, right? Take off 3. Take off 3 and take off 6. You have 3 elements. 1, 2, 3. Next one. Have we do a next one? No? Number 9. Number 9. Which of the following is empty? Can you have an intersection between prime and odd? Can you have an intersection between even and odd? Yeah, Milena? Which one you think wrong? Sorry, but which one's the answer? Which one empty? Which one empty there? Right? The intersection of odd and even. Right? Q and R. Boy. All right. One more and that's it, all you? Yes, this one. I didn't give it this formula. There's a formula for number of subsets. The formula is 2 to the number of elements. All right? Which one there is that? The answer is dog. You have 3 elements, so it's 2 to the power of 3. All right? All right. So that's it earlier. Right? We did not get to do consumer arithmetic. I'm hoping you can do that for yourself. And we didn't get to do area and volume. I'm hoping you can do that for yourself. Right? If you look back on the videos, I did an area and volume video some time ago. And I did a video on critical thinking through those questions, right? Number 6 or number 7. All right, on the groups, I will message me if you're not on the group. I will send the info for the next week Saturday class, right?